Hello, everyone. In this lecture, we are going to discuss some very, very important questions from DBMS. Those are frequently asked in different interviews, whether that is an interview for some kind of software developer post or at DBMS database administrator post, or most importantly, the assistant professor or this teaching post in computer science. So without any delay, let's start the question answering session. So first question is, what is DBMS? DBMS, we know, a kind of management system where you can consider a collection of program that actually facilitates users to create and maintain a database. So DBMS, as I have said, is a kind of management system, right? You can consider it as an interface or tool for performing different operations, like, creation of a database, insertion of data into it, deletion of data from it, updating the data. Okay. So this as a whole, a software in which data is stored in a more secure way as compared to the file-based system. Because database, then again we have to store the data. We have different other system like file-based system also, but DBMS differs from that because it is a more secured one, and you can easily perform different operations on those data stored in that database, right? Using DBMS, we can overcome many problems like, data redundancy, the data duplicacy problem, data inconsistency, easy access, more organized and understandable, like this. And there are different types of, means different database management system, DBMS examples we usually hear, like we all know about Oracle, then MySQL, SQL Server, Amazon, SimpleDB, that is cloud-based. So there are so many of them. Now, working of DBMS can be defined with this figure. You can see here, this is the kind of database. You consider it here, we are keeping here, suppose student data, student record, employee record. Now, this DBMS works as an interface between this database and the third party. Means third party in the sense that those who wants to access or who wants to means have data from that database, like here website code. Then what is database? Database is a logical, consistent, and organized collection of data that can be easily accessed, managed, and updated. Databases, also known as electronic databases, are structured to provide the facility of creation, insertion, and updation of data more efficiently and stored in the form of a file or set of files on a magnetic disks, tabs, and another sort of secondary devices. I hope you all know about the secondary devices. Means I am speaking about memory devices, right? Primary and secondary, this classification, I hope that you all are aware with you. This database mostly consists of objects. Like in RDBMS, we have been dealing with tables, and tables include records and fields. Fields are the basic units of data storage, which contain the information about a particular aspect or attribute of the entity described by the database. DBMS is used for extraction of data from the database in the form of queries. I have no doubt on that. So simply you just remember database is a kind of logical, consistent, and organized collection of data to access, to give the access more efficiently and to manage and update or manipulate the data in a very kind of organized way, in an efficient way. Now, if we talk about the advantages of DBMS over traditional file-based system, because DBMS provides us a lot of different facilities with the help of which we can deal with a kind of problems like, data duplicacy or data redundancy and inconsistency, difficulty in accessing data, data isolations, multiple files and formats, integrity problems, atomicity of updates, concurrent access by multiple users, security problem. These are the things that help actually DBMS to get more popularity of a traditional file-based system, right? Now, if we talk about, or if someone asks you, interviewer asks you that what is a database system, then you have to answer like that: the collection of the database and the DBMS software program or software together is known as a database system. So there are the databases, and to deal with those databases, we have the DBMS softwares, and together they are known as database system. Then, very important question: what do you mean by normalization in DBMS? Normalization is the process of minimizing redundancies in a database. So whenever you study database, DBMS, you will find this term again and again: redundancy, right? This is the redundancy what we actually try to minimize. So normalization is the process of minimizing redundancies in a database. It also helps to overcome insert, delete, and update anomalies. It is a process of analyzing the given relation schemas based on their functional dependencies and primary keys to achieve minimizing redundancy and minimizing insertion, deletion, and update anomalies. Those relation schemas that do not meet the properties are decomposed into smaller relation schemas that could meet the desirable properties. Now, you may wonder that what are these insert, delete, and update anomalies? These are actually some problems associated with the operation insertion, deletion, and updation. Suppose if you are trying to insert some data to the table, and then this problem occurs: insert anomaly. And suppose if you want to delete a particular data, but because of deletion, some kind of problem occurs, you can't delete even that data. Again, then same type of problem for update. So these type of problems occurs when redundancy exists in a table, or when so many data actually means gathered in the single table. So in such cases, we take the help of normalization. We break the table into smaller tables, and in that way we delete, or we overcome these types of anomalies. Okay, got it? Normalization. Now, what do you mean by denormalization in DBMS? So by normalization, we mean to minimize the redundancy. So obviously, denormalization is the opposite of it. This is the process of adding redundant data into a database. It is done after normalization to avoid costly joins. It is a common database optimization technique which helps to boost the performance of a database. So two, three things you have to remember with respect to this particular term, denormalization. So this is done to intentionally adding redundant data to a database, which is done after normalization process, so that we can avoid some joins, some complicated joins, or you can say some joins which are really costly in terms of, we can say, time complexity, and even it may occur some kind of complex problems. So overall, denormalization can be thought of as a database optimization technique to boost the performance of a database. Let's come to the next question. What is a checkpoint in DBMS? Checkpoint is a type of mechanism where all the previous logs are removed from the system and permanently stored in the storage disks. There are two ways which can help the DBMS in recovering and maintaining the acid properties. I hope you know about acid properties: atomicity, consistency, right? Isolation, and durability. So these properties can be maintained, and they are with the help of maintaining the log of each transaction and maintaining the shadow pages. So when it comes to log-based recovery systems, checkpoints comes into existence. Checkpoints are those points to which the database engine can recover after a crash as a specified minimal point from where the transaction log record can be used to recover all the committed data up to the point of crash. You got it? So checkpoint is the way of means what I can say to recover from a after a crash from a minimal point where the transaction log can be a record can be used to recover all the already committed data up to that point of crash. So this is a mechanism where all the previous logs are removed from the system and permanently stored in the storage disks. Then when does the checkpoint occur in DBMS? So checkpoint is like a snapshot of the DBMS state. Using checkpoints, the DBMS can reduce the amount of work to be done during a restart in the event of subsequent crashes. Checkpoints are used for the recovery of database after the system crash. So at least if you forgot everything, but don't forget this line. Why we use the checkpoint? Because they are used for the recovery of the database after some crash, system crash, so that we can retrieve those committed data up to that point of up to the point of crash. Now, checkpoints are used in the log-based recovery system. When due to a system crash, we need to restart the system. Then at the point, we use checkpoint so that we don't have to perform the transaction from the very starting. At least we can save our time, we can save the cost. Right. Then what are, next question, very important. What are super, primary, candidate, and foreign keys? Super key is a set of attributes of a relation schema upon which all attributes of the schema are functionally dependent. No two rows can have the same value of super key attributes. So super key either an attribute or it can consider as a set of attributes upon which all the attributes of that schema are functionally dependent. Remember, no two rows can have the same value of the super key attributes. Then candidate key is considered as a super key which has the minimal value. Or you can say candidate key is a minimal super key. Means no proper subset of candidate key attribute can be a super key. So the minimal one is the candidate key. Primary key. Primary key is one of the candidate keys. One of the candidate keys is selected as important, most important, and becomes the primary key. There cannot be more than one primary key in a table. Yes, there can be more than one candidate key, but there cannot be more than one primary key because out of those candidate keys, we select one as the primary key. Then what is foreign key? A foreign key is a field or a collection of fields in one table that uniquely identifies a row of another table. So obviously foreign key concept comes when there exists the referential integrity between two tables, say. So this key is actually identifying the row of another table. So say foreign key exists in table 2 and it identifies rows of table 1. Now, can you tell me what is the difference between primary key and unique constraints? Answer is the primary key cannot have null value, but the unique constraints can have null values. There is only one primary key in a table, but there can be multiple unique constraints. So remember, primary key cannot have null values. Okay, but yeah, also primary key cannot be more than one. But in the other hand, unique constraints can be null and can be more than one. Now tell me, what are the differences between DDL, DML, and DCL in SQL? So DDL means data definition language. We know they are the syntax, the commands create, alter, drop, truncate, rename. So these commands are used for what? for creating, or you can say defining that particular structure, or to perform an operation that directly impacts on the structure, like create, alter, drop, truncate, rename. So that's why they are the commands under data definition language. But to update what already exists, we need data manipulation language. And the commands under DML are select, update, insert, delete, etc. Don't confuse. Update comes under DML. Similarly, alter comes under DDL, because alter directly impact on the structure. Update, we are talking about some updation on the data inside the structure. So select, update, insert, delete, they come under data manipulation language. Create, alter, drop, truncate, and rename, they come under DDL. Then what is DCL? DCL are very important. Some commands, two important commands are grant and revoke. They are used for giving and removing user accesses on the database. So they are the part of data control language. One more thing is transaction control language, TCL, commit, rollback, save point. These are the commands used for managing the transactions in the database. So TCL is used for managing the changes made by the DML. Okay, let's come to the next question. What are the unary operations in relational algebra? Unary operations, projection and selection. Unary operations, those operations which use single operands. Like, projection, selections, rename, this, they are using single operands. So as selection in relation operations are used for like this type of operations. So remember, again, I'm telling, unary operations are those operations which involve single operands. Selection, projection, these are some very famous example. Then what is the difference between having and where clause? I hope you are aware with these two clauses, right? Having and where. Now, what is the difference between them? Having is used to specify a condition for a group or an aggregate function used in a select statement. The where clause selects before grouping. The having clause selects rows after grouping. Unlike the having clause, where clause cannot contain aggregate function. So I am repeating again. Remember, having is used to specify a condition for a group or an aggregate function used in a select statement. And this having, what happens? We select rows after the grouping. So having selects rows after the grouping, but where selects before grouping, and where cannot contain aggregate function. Well, next question is, what is RDBMS? RDBMS, Relational Database Management System. It is used to maintain the data records and indices in a table. So it is a form of DBMS which uses the taxa to identify and access data concerning over the other pieces of data in the database. This is a system that enables you to perform different operations like update, insert, delete, manipulation, and administer a relational database with minimum difficulties. Most of the RDBMS use SQL language because it is easily understandable and used for often. So what is SQL language actually? SQL is the structured query language, and we know we use language to perform some kind of processes, or you can say operations, or you can say this is a language with which we can communicate with the data, and this data in the database. This data exists in the database, and with the help of SQL, the RDBMS communicate with the data and perform the other operation. Then what do you understand by data model? Next question, right? Data model is specified as a collection of conceptual tools for describing data, data relationships, data semantics, and constraint. So data relationship, data semantics, meaning of those data, and the constraint. These models are used to describe the relationship between the entities and their attributes. Like we have few examples: hierarchical data model, network model, relational model, entity relationship model, very famous, that is known as ER model. Now, what are the different types of DBMS architecture? Different types of architecture exist, like single tier architecture, where data is readily available on the client machine. Two-tier architecture, DBMS software is present on the client machine and the database is present on the server machine. Three-tier architecture, a layer is present between the client and the server machine, and there is no direct communication between them. A client DBMS application on the client machine interacts with a server DBMS application on the server machine. So in case of three-tier architecture, a layer exists between client and server machine. Next question, what is join? Join, or you can say SQL join, is used to combine data from two or more tables based on a common field between them. Right, common field in the sense of attributes, common attributes, or you can more specifically say common columns. Now, what is identity? Identity or auto number is a column that automatically generates numeric values. A start and increment value can be set, but most DBA leave this at GUID column also generates number. The value of this cannot be controlled. Identity and GUID columns do not need to be indexed. So just remember that identity is a kind of column that automatically generates some IDs or some numeric values that are incremented with respect to the different values generated, right? Then what is a view in SQL? Very important. How to create a view? So view is a virtual table based on the result set of an SQL statement. We can create it using a create view syntax. So remember, what is view? View is a virtual table over the original table. Now we can create it with the SQL command, create view, view name, right, as select column names from table name where condition. So these view, say V1, will be created from what? From this table. And from this table, we are specifying what are the columns to be included in that view with respect to what condition. Okay, so that's right. Create view, view name as select column name or names from table name where condition. Well, next question, what are the uses of view? First of all, views can represent a subset of the data contained in a table. So consequently, a view can limit the degree of exposure of the underlying tables to the outer world. So works as a security purpose, right? A given user may have permission to query the view while denied access to the rest of the base table. Views can join and simplify multiple tables into a single virtual table. Views can act as aggregated tables where the database engines aggregates the data, that is where we are using sum, average, and presents the calculated results as a part of the data. Views can hide the complexity of the data. Views take very little space to store. Database contains only the definition of a view, not a copy of all the data which it presents. Depending on the SQL engine used, views can provide extra security. Just remember these few points. Next question. Define a relation schema and a relation. A relation schema is specified as a set of attributes. It is also known as a table schema. It defines what the name of the table is. It's also known as a blueprint with the help of which we can explain that how the data is organized into tables. And this blueprint contains no data. Because why? Because it's a kind of means you can consider is a kind of structure where actually specifying the set of attributes only, but it is actually not containing the data. But a relation is specified as a set of tables. A relation is the set of related attributes with identifying key attributes. Let's take an example. R be the relation which contains the set of tuples T1, T2, T3 up to Tn. And this each tuple is an ordered list of n values. Say this T1 has some values, T2 has some values. So T1, or you can say consider say T as a whole, V1, V2, Vn, different values. Well, now it is clear to you. So next question is, what is the degree of a relation? The degree of a relation is a number of attributes of its relation schema. A degree of relation, also sometimes referred as cardinality. It is defined as the number of occurrences of one entity which is connected to the number of occurrences of other entity. There are three degree of relations, like one to one, one to many, and many to one, or you say many to many. Now, what is relation? So I hope degree is clear. You just remember that how many number of attributes in a relational schema that is being specified with the degree. Again, cardinality is the number of occurrence of entity. One entity connected to the other entity. Like suppose two relations are there, are two, that the possible cardinality happens like one to one, one to many, many to many. Okay. What is relationship? Relationship is defined as an association among two or more entities. Three types of relationship exist. Thus, I told you one to one means one record of any object can be related to one record of another object. One to many, one record of any object can be related to many records of other object and vice versa. Then many to many, where more than one records of an object can be related to n number of records of another object. So these are the different types of relationship. Then, very common question that what do you understand by data abstraction in DBMS? Well, this is a process of hiding irrelevant details from users. Because database systems are made up of complex data structures, so it makes accessible the user interaction with the databases. Let's take an example. We know that most of the users prefer those systems which have a simple GUI, that means no complex processing. So to keep the user tuned and for making the access to data easy, it is necessary to do the data abstraction. In addition to it, data abstraction divides the system into different layers to make the work specified and well-defined. You just remember data abstraction means hiding the irrelevant details. Hiding those, you can also say you can also say like that, hiding the confidential details. The outside world will know that actually what is happening, but how it is happening being hidden with the help of data abstraction. Now, there are three levels of data abstraction. What are they? This question may be asked. So, first layer, or you can say first level, is physical level. Physical level is the lowest level of data abstraction. It describes how data are stored. Logical level. It is the next higher level of data abstraction, and it describes what data are stored in the database and what the relationship among those data is. Then view level is the highest level of data abstraction, and it describes only part of the entire database. For example, user interacts with the system using GUI and fill the required details, but the user doesn't have any idea how data is being used. So the abstraction level is entirely high in view level. Then the next level is for programmers. As in the level, the fields and the records are visible and the programmers have the knowledge of this layer. So the layer of abstraction here will be a little low in view level. And lastly, means this is the middle one, right? Middle one, I told you now, what is that? Middle one is the logical level, where what data are stored and what the relationship between the data. But the next one is the physical level, where exactly how data or where exactly data is stored, that is the thing being denoted. Okay. Well, let's come to the next question. What is trigger? Trigger is a code associated with insert, update, or delete operations. This code it is executed automatically whenever the associated query is executed on a table. Triggers can be useful to maintain integrity in the database. Just let me explain you in brief or in simple way that suppose some condition is there, C1. If this condition favors, then automatically some updation will happen in that database. And this is known as trigger, that code which is associated with this particular update operation. Similarly, trigger can be associated with insertion operation also, delete operation also. And this is executed automatically whenever particular condition is satisfied or particular associated query is executed on a table. And we use it to maintain integrity in the database. Next question, what is stored procedure? Stored procedure is like a function that contains a set of operations compiled together. It contains a set of operations that are commonly used in any application to do some common database tasks. Just remember that this stored procedure is a kind of a number of set of operations compiled together into a function. So stored procedure is nothing but a function, which is maximum time used in application to do some common database tasks. Well, then what is the difference between trigger and stored procedure? Unlike stored procedure, trigger cannot be called directly because there should be some associated queries. If those happens, then trigger automatically happens. Right? But we can call the stored procedure. Next question. What is transaction? What are ACID properties? I already told you what is ACID property. Let's again discuss. A database transaction is a set of database operation that must be treated as a whole, which means either all the operations are executed or none of them. Means half or partial cannot be happen. So an example can be a bank transaction from one account to another account. Either both debit and credit operation must be executed or none of them. Half cannot be, means half credit, half debit. This should not happen, right? And ACID told you already, ACID atomicity, consistency, isolation, and durability. These are some properties, set of properties that guarantees database transactions are processed reliably. Well, next question is, what are indexes? Remember, the database index is a data structure that improves the speed of data retrieval operations on a database table at the cost of additional writes and the use of more storage space to maintain the extra copy of data. I'm repeating again, this is a data structure which improves the speed of data retrieval process. But for that, some cost happened. And what are they? That additional write and use of more storage to maintain the extra copy of data. Now, data can be stored only in one or the on a disk to support faster access according to different values. Faster search like binary search for different values is desired. And for this purpose, indexes are created on the tables. These indexes need extra space on the disk, but that allow faster starts according to the different frequently searched values. So you remember index, I hope you already know that why index term is being used, because these are kind of data structure, or you can say where some values are there. From that value or from that reference, you can easily access the data. But the thing is that to store those indexes, we need some extra space. Well, let's come to the next question. Next. What are clustered and non-clustered indexes? Clustered indexes are the indexes according to which data is physically stored on a disk. So only one clustered index can be created on a given database table, while non-clustered indexes do not define the physical ordering of data, but logical ordering only. Typically, tree is created was leaf point to dig sequence. BT or B plus T, these are used for these purposes. If you have already gone through my lecture on important interview questions on data structure, I have explained this part. So got it? Just remember cluster indexes, that index which actually means form the cluster of the data that are physically stored on the disk. So this is somehow you can say physical in nature, physical, right? Now, if it is actually logical, just indexes. Difference between clustered and non-clustered indexes clear. Next question is, what is clause in SQL? Clause in SQL is a part of a query that lets you filter or customize how you want your data to be queried to you. So it just remember, clause is nothing but a filter, and it actually customizes that how you want your data to be retrieved or queried from that database. Then what is live log? Live log is a situation that can be defined as when two or more processes continually repeat the same interaction in response to changes in the other processes without doing any useful work. These processes are not in the waiting state, and they are running concurrently. This is different from deadlock, remember, because in deadlock, all processes are in the waiting state. But here, what happens? All the processes are not in the waiting state, but they are actually running concurrently. So you got the difference between live log and deadlock also. I'm repeating again, this is live log is a situation which can be defined as when two or more processes continually repeat the same interaction in response to changes in the other processes without doing any useful work. But these are not in the waiting state, but they are actually running concurrently. While in a deadlock situation, all the processes are in the waiting state. Next, what is QBE? QBE. So QBE, that is query by example, represents a visual or graphical approach for accessing information in a database through the use of query templates called skeleton tables. It is used by entering example values directly into a query template to represent what to be achieved. QBE is used by many database systems for personal computers, and this is a very powerful facility that gives the use a capability to access the information a user wants without the knowledge of any programming language. Queries in QBE are expressed by the skeleton tables, and it has two distinct features, and they are like kind of two-dimensional syntax. So you just remember the QBE is for those who doesn't want to deal with those tactical kind of queries. It's because it is already a kind of query template. Next, what is DML? Already told you. DML for manipulating the data. Now, for that, we use either select, update, insert, delete. And remember, they can be of two types: procedural DML or low-level DML. So procedural DML requires a user to specify what data are needed and how to get those data. While non-procedural DML or high-level DML, this requires a user to specify what data are needed without specifying how to get those data. So DML are of two types: procedural, that is the low level one; non-procedural, that is high level one. Procedural, where you need to specify what data what data are needed and how to get it. But in case of non-procedural, you just specify what data are needed, but you are not specifying how to get this data. Then explain the functionality of DML compiler. DML compiler translates DML statements in a query language that query evaluation engine can understand. It is required because DML is the family of syntax element which is very similar to the other programming languages that requires compilation. Why we do the compilation? Because that's to transform from machine level language to the high level language, right? Here also DML compiler needed, because then only those syntax elements can be presented to the engine in such a way that it understands what actually query wants. So DML compiler is essential to compile the code in the language which query evaluation engine can understand and then work on those queries with proper output. Well, next question is, what is relational algebra? Relational algebra is a procedural query language. Remember, relational algebra is a procedural query language which contains a set of operations that take one or two relations as input and produces a new relationship. This contains some basic operations for the relational model. The decisive point of relational algebra is that it is similar to the algebra which operates on that number. Now, this relational algebra operates on the data. Some fundamental operations are select, project, set difference, union, rename, where select and project are the unary operators. Then, what is relational calculus? As you got it, that relational algebra is a procedural query language, while relational calculus is a non-procedural query language, which uses mathematical predicate calculus instead of algebra. Relational calculus does not work on the mathematical, or you can say mathematics fundamentals like algebra, differentials, integration. That's why it is known as predicate calculus. Two types of relational calculus exist: tuple relational calculus and domain relational calculus. Next question, what do you understand by query optimization? The term query optimization specifies an efficient execution plan for evaluating a query that has the least estimated cost. Right? So means we try to optimize the query. The concept of query optimization came into the frame when there were a number of methods and algorithm existed for the same task. Then the question arises that which one is more efficient, and the process of determining that efficient way is known as optimization, or you can say, in this case, query optimization. So many benefits are there for because of this query optimization we get. First, it reduces the time and space complexity. Second, more queries can be performed as due to the optimization. Every query comparatively takes less time. Then user satisfaction, as it will provide output fast. Next, why are cursors necessary in embedded SQL? A cursor is an object used to store the output of a query for row-by-row processing by the application programs. SQL statements operate on a set of data and return a set of data. On the other hand, host language programs operate on a row at a time. The cursors are used to navigate through a set of rows returned by an embedded SQL statement. That SQL statement is the SQL select statement. So you can just compare this cursor with a pointer. Okay, so clear? So just define cursor is an object used to store the output of a query for row-by-row processing by the application program. Then what is the purpose of normalization in DBMS? I explained very clearly that, first of all, to deal with the redundancy, right? It helps remove the duplicate data, database anomalies. It avoids, or you can say, it avoids the duplicate data or no repeating groups in a table. Then what is the difference between database schema and a database state? The collection of information stored in a database at a particular moment in time is known as database state. Remember, when this database state or state comes, there should be a particular moment or time. While the overall design of the database is known as database schema, or you can say the skeleton. Then next, what is the purpose of SQL? Told you already, structured query languages to interact with the data in a relational database. Then explain the concepts of primary key and foreign key. Already explained to you that primary key uniquely identify the data, while foreign key is mainly used to link two or more tables together, as this is a particular field in one of the database tables which are the primary key of some other tables. Say two tables are there, employee and department, but both of them have some common field or column ID, where ID is the primary key of the employee table, while this is the foreign key for the department table. So ID in the case of employee table acts as a primary key, while in the department table also ID exists, and there we will call it as a foreign key. So both these two tables, employee and department, being associated with each other with this foreign key ID. Can you tell me the difference, or you can say main difference between primary key and unique key? Yes, the primary key and unique key. Primary key never can have a null value, but unique key may consist of null value. Tell you, na? I tell you that what is the difference between primary key and a unique constant, the same thing here. Okay, but the question may be asked in a different way also. And one more thing, you should not forget that there can be only one primary key, while there can be more than one unique key or unique constraint in a table. Well, what is the concept of subquery in terms of SQL? Subquery is basically the query that is included inside some other query and can also be called as an inner query, which is found inside the outer query. Then what is the use of drop command? You got it, not drop command is the DDL command. Now, what is the use of this command and what are the differences between drop, truncate, and delete commands? Drop is a DDL command used to drop or delete the existing table, so directly impacting the structure. So it is used to delete the existing table, database, index, or view from the database. Now, what are the differences between drop, truncate, and delete? Drop and truncate commands are the DDL commands. Drop and the truncate both are DDL commands that are used to delete the tables from the database. And when we make use of a drop command, the tables get deleted permanently. All the privileges and indexes that are related to the table also get deleted. This operation cannot be rolled back and so should be used only when necessary. Remember, drop command or drop operation cannot be rolled back and everything will get deleted permanently associated with that particular table. So it should be used cautiously. While, however, in the case of truncate, only the data stored in the table is deleted and the structure of the table is preserved, and you can reinsert the data by the use of insert into close. It can be rolled back until the commit has been made. So you got it, truncate can be rolled back also, and that is possible until the commit has been made, and it only delete the data, not the structure. So you can easily reinsert the data with the help of insert into clause. Then delete command, this is, you already got it while I was explaining DML. The delete command is a DML command, and this used to delete the rows from the table, and that can again be rolled back. However, it is considered slower than truncate. Using the delete command, we can delete one or more specific rows from the table. So truncate and delete performing the same thing, but truncate is faster than delete commands. That is the difference between drop, truncate, and delete. Repeating again, drop and truncate DDL, while delete is DML. Drop permanently delete the structure, so cannot be rolled back. Truncate only deletes the data, can be rolled back until the commit has been made. Delete also can be rolled back, and it is a DML command, but it is comparatively slower than truncate command. Well, next question is, what is the main difference between union and union all? Union and union all, they are used to join the data from two or more tables. But union removes the duplicate rows and picks the rows which are distinct after the combination or after combining the data from the tables. Whereas union all does not remove the duplicate rows, it just picks all the data from the tables. Next question, what is a correlated subquery in DBMS? Well, a subquery is also known as a nested query. This is a query written inside some other query. Now, when a subquery is executed for each of the rows of the outer query, then it is known as a correlated subquery. You got it, now? So subquery is obviously under inside one outside query. Now, if this query is executed for each of the rows in the outer query, then it becomes a correlated subquery. Let's take an example of non-correlated subquery. Select all from employee where RIA in select name from the department where employee ID is equal to department employee ID. Here inner query is not executed for each of the rows of the outer query, because there is a condition employee ID should be equal to employee ID of department table. Well, next question is explain entity, entity type, entity set in database. Entity. Entity always represent a real-time object, right? Entity is an object, can be place or thing which has its independent existence in the real world and about which data can be stored in the database. For example, any person, book, etc. This person, book, they are entities. Now, entity type, right? It is a collection of entities that have the same attributes. For example, student table contains rows in which each row is an entity holding the attributes like name, age, ID of the students. Hence, student is an entity type that holds the entities having the same attributes. Got it? So don't confuse. Entity is the real-time object, can be attribute also. Like in a student table, name, age, ID, all are representing some entity. So because suppose in a student table, student can be say Rahul, student can be say Thomas, student can be say Ria. So these three different students will have different values, name, age, ID. So this name, age, ID independently to each particular Ria or Rahul or Thomas, they are entity. But as a whole, if we consider this Ria, Thomas, and say Rahul, they are what? They are actually entity type student. I hope now it is clear to you. Now, entity set is a collection of entities of the same time. Say a collection of employees of a firm. Clear? Entity, entity type, entity set. Repeating again, entity real-time object like Rahul, say Ria, then entity type student, then entity set, collection of different entities of the same type. Well, now what integrity rules exist in the DBMS? Two integrity rules. First, entity integrity. This states a very important rule that the values of a primary key cannot have a null value. Then referential integrity. This is related to the foreign key, which states that either the value of a foreign key is a null value or it should be the primary key of the any other relation. Repeating again, entity and integrity means primary key cannot have a null value. Then referential integrity, this states that either a value of a foreign key is a null value or it should be a primary key of another table. Then what is ER model? ER model in DBMS is the entity relationship model that is based on the concept of entities and the relationship that exists among those different entities. Then what is a functional dependency in DBMS? This is basically a constraint that is useful in describing the relationship among the different attributes in a relation. Say, there is some relation R1 which has two attributes Y and Z. Then functional dependency among these two attributes Y and Z can be shown as Y implies Z. This is a functionally Y is implying Z. That states that Z is actually derived from Y, or you can say Z is functionally dependent on Y. Well, if functional dependency concept is clear, let's come to the different normal forms questions. What is first normal form in DBMS? First normal form, easiest form of the normalization, which states that domain of an attribute should have only atomic values. Atomic values, right? The objective of this to remove the duplicate columns that are present in the table. Then second normal form, if it satisfies two conditions. First, the table should already be in one normal form, that is atomicity is there, right? Then each non-prime attribute of a table is said to be functionally dependent in totally on the primary key. No partial dependency should exist. Then third normal form, a table in third normal form, it satisfies two conditions. First, the table should already be in two normal form. Then each non-prime attribute of a table is said to be non-transitively dependent on every key of the table. That means that transitive dependency should not exist. Then only you can say that is a third normal form table, satisfied table. Then what is BCNF in DBMS? BCNF, boys code normal form. This is tricard and the third normal form. And it is said that a table is said to be in BCNF if first it is already in the third normal form, and then for any functional dependency x implies y, x should be the super key of the table. Then my question to you, what is the condition for fourth normal form and what is the condition for fifth normal form? Answer through comments. Well, let's come to the next question. What is a clause in terms of SQL? Told you already. Clause. What is that exactly? Now, it is used, I mean, this clause is used in SQL queries to fetch specific data as per the requirements on the basis of some condition put in the SQL. And it is helpful in picking the selective records from a complete set of records. For example, there is a query that has a where condition or the query with the having clause. So you can consider it as a kind of filter. Right. Now, how can you get the alternative records from the table in SQL? If you want to fetch the odd numbers, then the following query, like this one, select employee ID from select row number, employee ID from employee, where row number 2 means this modulus we are using should be 1. If you want to fetch the even number, then what will happen? This same thing you have to write only this mod row no means row number 2 should be equal to 0. So 1 is for odd and the other for even. Well, not very much important, but at least you have to familiar with this syntax. Well, how is the pattern matching done in SQL? Well, in that case, you have to answer like with the help of like operator. Like operator helps us or make it possible to perform pattern matching in SQL. Percentage is used with the like operator when it matches with a 0 or more characters, and this is used to match one particular character. Like, for example, select all from employee where name like B percentage. Then select all from employee where name like Hans Des. So this particular star is used with the like operator to matches with 0 or more characters, while this underscore is used to match the one particular character. So in this way, we can have the value like that is starting with this B and another one, this all where Hans is there. It's a way of pattern matching, right? I hope you are familiar with pattern matching. At least in Unix, you already did this. The next question is, what are the different types of joins in SQL? Different types of join. Join is used to join the data or rows from 2 or more tables on the basis of a common field or column. Now, inner join is there. 4 types of join. Okay, 4 types of SQL joins exist. Inner join. Type of join used to fetch the data among the tables which are common in both tables. Left join returns all the rows from the table which is in the left side of the join, but only the matching rows from the table which is on the right side of the join. Then right join returns all the rows from the table which is on the right side of the join, but only the matching rows from the table which is on the left side of the join. Full join, this returns the rows from all the tables on which the join condition has been put and the rows which do not match or hold null values. Then explain the stored procedure. Already told you, stored procedure is a group of SQL statements in the form of a function that have some unique name and is stored in the relational database management system and can be accessed whenever required. Told you now what is the difference between the stored procedure and that one? Trigger, right? Stored procedure can be called, but trigger happens only when that particular condition satisfies. Next question, what do you mean by entity type extension? Compilation of similar entity types into one particular type, which is grouped together as an entity set, is known as entity type extension. What is conceptual design in DBMS? Conceptual design is the first state in the, or can say first stage in the database design process. The goal at this stage is to design a database that is independent of database software and physical details. The output of this conceptual design is a conceptual data model that describes the main data entities, attributes, relationship, and constraints of a given problem domain. Then differentiate between logical database design and physical database design. So how this separation leads to data independence? Well, logical database design and physical database design. Tasks: maps or transform conceptual schema from the high-level data model into relational database schema. Specification for the stored database in terms of physical storage, structures, record placement, and indexes are designed. And choice of criteria: mapping can process in two steps: system-independent mapping, but data model dependent. Tailoring the schemas into specific DBMS, and the conditions that is required are response time, space utilization, transaction throughput. Okay, result DDL statement in language of the chosen DBMS. Just remember, let me tell you in briefly, although the answer seems to be kind of complex, just remember that logical database design basically deals with the kind of conceptual things, right? The exact design or exact where the data is being stored is deal with physical database design. Okay. Now, what are temporary tables? How they are used? Temporary tables exist solely for a particular sessions where data persists for the duration of the transaction. These are generally used to support specialized rollups or specific application processing requirements. Unlike a permanent table, space is not allocated to a temporary table when it is created. Space will be dynamically allocated for the tables as the rows are inserted. The create global temporary table command is used to create a temporary table in the Oracle. Remember, this exists only for a particular session, not just a kind of permanent kind of things. Now, what are the different types of failure that occurred in Oracle database? Now, if you already did some experiments in Oracle, then you are very much familiar with those failures. If you had gone through, like, statement failures, bad data type, insufficient space, insufficient privileges like object privileges to a rule, user process failure, user perform an abnormal disconnect, user session abnormally terminated, user program raise and address exception, user error, user drops a table, user damage data by modification, instance failure, media failure, user drops a table, user damages data by modification, alert logs, records informational and error messages. All instance startups and shutdowns are recorded in the log. Well, let's come to the next question. What is the main goal of RAID technology? RAID stands for redundant array of inexpensive disks. Redundant array of inexpensive or sometimes independent disks is also said. This is the method of combining several hard disk drives into one logical unit. Two or more disks grouped together to appear as a single device to the host system. This was developed to address the fault tolerance and performance limitation of conventional disk storage. It can offer fault tolerance and higher throughput levels than a single hard drive or a group of independent hard drives. While arrays were once considered complex and relatively specialized storage solution, today they are easy to use and essential for a broad spectrum of client-server applications. So RAID, redundant array of inexpensive disks, to merge or combine several hard disks into one logical unit. Well, what are the integrity rules in DBMS? This is one significant aspect while maintaining the database. Data integrity is enforced in the database system by imposing a series of rules. Those set of integrity is known as integrity rules. Two rules are there, I already told you, and in entity integrity, that is primary key cannot be a null value. Referential integrity, if foreign key can either be, means foreign key can either be null or it can be a primary key of the other relation. Last question of this session. What do you mean by extension and intention? Extension is the number of tuples present in a table at any instance. It changes as the tuples are created, updated, and destroyed because it represents the number of tuples present in a table at any instant. Now, actual data in the database change quite frequently. So the data in the database at a particular moment in time is known as extension or database state or snapshot. It is totally time dependent. Now, intention is also known as the data schema and defined as the description of the database, which is specified during the database design and is expected to remain unchanged. The intention is a constant value that gives the name, structure of tables, and the constraint laid on it. So remember, intention, also known as data schema, and it defines the description of the database and it actually specified during the database design and remain unchanged. So it is a kind of constant value that gives the name, structure of the tables, and the constraint laid on it. So this is the difference between extension and intention. These are the references. So I hope these questions will help you to prepare for any interview that you think that the questions on the DBMS will be asked. So with this, I'm ending this session. Thank you very much.